Okay, just a brief overview. Um, I'll be answering first order differential equations. Right now, specifically, we are going to answer linear first order differential equations. Um, let's just finish this problem and I'll show you how it's solved in the next problem. Okay, so I just want to check if this question is answered correctly. Um, I am verifying it right now. It is indeed correct. Okay, so let's answer number 12. As much as possible, I'd leave number 11 at the top so we can answer 12 here. Okay, so ideally, I'd be able to teach first variable separable. That's actually one of the approaches in solving first order differential equations. Um, the next is supposed to be exact. This is the third one. But I guess I'll start here first. If you want to test if a differential equation is variable separable, um, how am I going to approach this? I'll just say for now that this is not variable separable. Let's try to organize first the equation in such a way that dy is at the left and dx is at the right. So just like what I did here. Okay, so yeah, let's do that. 1 over x dy minus transpose xy to the right side. We will have x squared plus xy. And then, yeah, we multiply both sides with dx so that we can transpose dx to the right side. Okay, now we can see more easily if the differential equation is variable separable. By the looks of it, it isn't. You cannot solve this by separation of variables. The second option is testing for exactness. You want to see if you can solve this. Let me show you. So m, for an exact differential equation, the standard form, if I'm not mistaken, is m dy plus n dx equal to 0. So m, this is our m right now. N is this one. So x squared plus xy. Okay. And we want to find the derivative. If you test for exactness, you know that it is exact if partial m over partial y is equal to partial n over partial x. So we basically just derive here 1 plus x. Since you're deriving with respect to y, this is 0. Everything is considered a constant. Here, you derive with respect to x. So 2x plus 1 plus y. So as you can see, they are not the same. Therefore, you say that this is not exact. So there are actually two other options that you can test for if ever this isn't linear, but these questions are already linear. So yeah, let's solve using the linear approach. So where do we start? You want to test first if it is linear in y or x, the two variables we have. And right now, it's pretty new. I think it is linear in both x and y. Let me just verify that. So is 1 plus x dy equal to x squared plus xy dx linear in x or y or both? My hypothesis is it is linear in both x and y. But let's see. So it says it is linear in y, but not in x. I have an idea. What if, coming from here, we transpose this to the right side by division? I think this gives us the idea that it is only linear in y, because the x variable is seen to be in the denominator position. So far, from what I observed, if one of the variables is located in the denominator position, then you can conclude that it is nonlinear. So far, what you see is that y is in the numerator only, and another detail is that it is raised to 1. So it gives you the idea that it is linear. Okay, so now that that's settled, let's convert what we have right now into the standard form of a linear first order differential equation. That is um, this. So dy over dx, in other words, y prime, plus p of x times y equal to q of x. So let's see. First things first, we bring back dx to the left side. So dy over dx is equal to x squared plus x. No. Let's start distributing the denominator to each term in at the top. So we want to see if this could help in the simplification process. Um, okay. Oops, sorry. The x is already in the left side. Right now, the p of x times y is this one. So we separate them in such a way that we transpose it to the left side, x over 1 plus x times y, and then the rest. So these two end up at the right side. So if you can visualize, p of x is actually this one. The y is this one. Q of x is this one. Okay? So now that it is in standard form, well, yes, we identify what p of x is. Essentially, when solving linear differential first order equations, the idea is you need to multiply the standard form with an integrating factor. And in order to identify that integrating factor, it's actually the next step after this. Let me just finish writing. The integrating factor, or IF, is equal to e raised to the integral p of x dx. This is the reason why we look for p of x, because that's what we use here. So substitute, then we just integrate. So what do we do? What if u is 1 plus x? Du is 1. No, dx. That won't work. How do we integrate this? Let's try, since the degree of the numerator and denominator is the same, we can try long division. Okay, so 1 x plus 1. 1 plus 1 over x plus 1. 1 here, and then what's at the bottom is at the numerator. Then you copy the denominator as this one. Okay, so we haven't derived yet. We just changed the form. Okay, so we write e raised to integral of 1 plus 1 over x plus 1 dx. It looks like it appears to be that I think we made it longer. It's exactly the same. Let me confirm if the long division was done correctly first. Okay, correction. This is supposed to be minus 1. So minus there. Okay. This is not the same as this. So we're in the right we're in the right track. We're on the right tracks. Integral of 1, that's gonna be x. Let's try u equal to x plus 1. Du is equal to dx. I'm seeing integral du over u. That is equal to the ln natural log of u, which is x plus 1. Okay. And then e raised to x, e raised to negative ln x plus 1. I think we can rewrite it that way. We can transpose the minus sign to the exponent position. That is a property of logarithm. E raised to x, cancel e and ln. We get x plus 1 raised to negative 1. I just want to verify if this integrating factor is correct so far. You have to be sure because it's a really long solution and it doesn't feel good if you don't get it right. And yeah, let's see. 1 over x. 1 plus x. It's pretty similar. What I'm seeing right now is that the integrating factor is said to be 1 plus x over e raised to x. It's exactly the opposite of what we have right now. Although it's the same, essentially the same terms. What could have possibly gone wrong? Okay. In the formula, the standard form is plus, right? This one is a minus. That minus sign belongs to p of x. So essentially, there has to be a minus sign here. Okay. That's very critical. So negative x and then plus. Okay. Yes, that makes sense now. So when we simplify, it's actually x plus 1. That's at the top. At the bottom is e raised to x. Precisely. Okay, we're correct so far. We're good. Now that we have identified the integrating factor, let's write again the standard form. That is dy over dx minus x over 1 plus x times y equal to x squared plus x over 1 plus x. So multiply the entire equation by the integrating factor to make it exact. Okay, so x plus 1 e raised to x times dy over dx minus, I think these cancel. These will cancel. And then just copy the... No, not copy. I don't think you have to simplify it. You can actually. Okay. At the left side, our goal is basically we see this as a result of product rule. So since this particular problem, we identified that it's linear in y, Here, we write y here, which is this one. It came from here. I'm already teaching you the technique. And then the integrating factor is always going to be multiplied to it. It's very crucial. X plus 1 over e raised to x. Let's say in this scenario, it is linear in x. This is what you put here. And the integrating factor multiplied to it. Okay? And if the scenario were to be linear in x, the standard form is actually going to be dx over dy, or x prime, plus p of y times x equal to q of y. So this is if ever it were to be linear in x. This is the standard form for linear in y. Okay, there's a difference. Okay, so transpose, you multiply both sides by dx. E raised to x times quantity x plus 1 dx. Okay. Now we integrate. These cancel. So what we have in the left side is just this. At the right side, okay, so I factored just for precautionary measures. But since we're going to integrate, it's better that it were to be in a form that is most simplified. So x squared plus x squared e raised to x plus x e raised to x. Okay, so I'm afraid we're gonna have to do integration by parts if u substitution would not suffice. Let's see. Nope. Okay, I think we have to do integration by parts. Integral of x squared e raised to x dx. Let's distribute dx already. Plus integral of x e raised to x dx. But I think it's not gonna be that hard. I've seen this example. I think it's the exact same question a while ago, coming from an easier problem. So I think it's pretty common, and that's a good thing. So okay, let's deal with the first term. Let's say u is x squared. Integral dv is e raised to x dx. Okay, basic. Other side is gonna be 2x dx. Okay, x squared e raised to x minus v du. Okay, that's actually pretty interesting. Do we still have to integrate this? Because right now it's exactly the same as this. We can just simplify the old-fashioned way. I think this would work. -2 and +1. In that case, when we combine them, we're gonna have x e raised to x dx. I think that's valid, although this is actually the first time for me to actually do that. Integration by parts. U equal to x, du equal to dx. dv, the integral dv is equal to e raised to x dx. V is equal to e raised to x. U, v minus integral v du. Okay. This is just e raised to x. Distribute the minus sign. Okay? And then equate. Okay. Okay, so combining all these, I think we can factor e raised to x. Math is really beautiful. um, okay, so the general solution, that's usually the final answer, at least for now, is in the form. So since this is, well, by default, you basically just solve for y. So after integration, yes, after integration, there has to be plus c, since we're dealing with indefinite integrals. Um, Basically solve for y. I am yet to see a scenario where we have to solve for x. Maybe if it's linear in x. Let me just verify. In yes, we have to solve for x if it's linear in x. But when it comes to variable separable and exact, I'm not sure if you have to solve for x, but usually solve for y. Anyways, um, so multiply both sides by e raised to x. That becomes e raised to x plus x, that's e raised to 2x. Don't forget c. c e raised to x. Y is equal to... Can we factor this? Let's see. Oh no, that's not possible. The middle term has to be negative 2x. That's not the scenario right now. So we cannot factor. So we have x plus 1. This is the final answer. The general solution. Let's verify if it's correct. I have a discrepancy from the answer key. I wonder what went wrong. the denominator is correct, as well as the constant. We'll just leave it like this for now. It's taking too much time unreasonably. But this is what Gemini proposes as the answer. So yes, this is the same. Let's try 13. So y prime can be rewritten as dy over dx. Let's transpose this to the right side. Okay. Divide everything by x squared. I'll keep y at the right side, just so, because I think this is gonna be a p of x times y. It's easy. I think it's easy to identify at this point. Oh yeah, we cannot assume yet if this is linear or not. So obviously, oh yeah, that's actually what we're doing right now. We want to see if it's variable separable. If it were to be variable separable, you don't have to overcomplicate things, because it's much easier if what you're dealing with is solvable by separation of variables. So, and then dy is equal to a raised to x over x squared minus, okay. So clearly this is not variable separable. It's really complicated. Fractions pa. There is still fractions. So not variable separable. We want to test if this were to be exact. I don't think so. I mean, if we're gonna find the integral of, if we're gonna find the derivative partial m over partial y, when m right now is equal to 1. So that's 0. How about for n? Partial n over partial x. So this is definitely not 0. So not exact. That's the point I'm trying to make. So now let's convert into standard form. So transpose to the left side, this one. Okay, so p of x is equal to x plus 2 over x. Q of x is equal to e raised to x over x raised to 2. Now, let's identify the integrating factor. Again, it is equal to e raised to p of x dx. Now, substitute. Actually, p of x could be rewritten as 1 plus 2 over x, or 1 plus 2x raised to negative 1. Or yeah, you can just leave it as is. It looks much better if your integrand is not in fraction form. But in this case, it's an exception, because the degree is only raised to 1. Okay, so replace. Okay, simplify further. The first term, that's going to be x. And then we have 2 dx over x. That's gonna be 2 ln of x equal to e raised to x, e raised to ln x, 2 ln x. But you can bring 2 in the exponent position. That's what you have to do because we're gonna cancel e and ln. So what you're left with is x squared. So x squared ex, e raised to x. That is the integrating factor. It's fun, right? It feels fun. What's next? Okay, bring back the standard form. It's time to start multiplying it by the integrating factor. So what is it again? X squared plus e raised to x. Okay, simplify. X e raised to x times x plus 2y. And then that's gonna be e raised to 2x. Okay? D over dy, no, sorry, dx. It's always d over dx when it is linear in y. Do we know that this is linear in y? We haven't yet. So clearly this is not linear in x because x is in the denominator position. You see y in the numerator position and you have dy. So this is linear in y, not x. So far, I've been answering quite a lot of problems already. We're already at problem 13. So far, everything is linear in y. I am yet to encounter a linear in x question. So let's just keep going. Okay. So everything here is x. What we just want is the y. And then multiply it by the integrating factor, which is x squared e raised to x. Case dismissed for whatever you have to do in the left side of the equation. In the right side, it is e raised to 2x. So x squared y e raised to x equal to dx e raised to 2x. Integrate x squared y e raised to x. Has to be here. Looks better. U is equal to 2x. Du is equal to 2 dx. So 1/2 e raised to 2x. Then you simplify, solve for y. Divide both sides by x squared e raised to x. Okay. Okay. I think that's it. Oh, wait. Don't forget the plus c. So, in that case, plus c over x squared e raised to x. Let's verify if that's correct for number 13. E raised to x, 2x squared. Okay, yeah, this is correct. So this example was easier compared to 12. Let's now answer number 14. So x dy over dx plus 1 plus x times y Transpose this to the right side. Okay. Divide both sides by x. Okay, and then I can already smell what variable is nonlinear just by looking at it. There is a policy wherein if you see a variable associated with a transcendental function, for example sine, then it is obviously, well, it is automatically rather considered nonlinear. And on top of that, you also see x in the denominator, so clearly it is nonlinear. What is linear is y. Okay? But before that, you want to know if it's variable separable? I don't think so. It's not likely. If is it exact? No, I don't think so either. From what I observed so far, it, when a first order differential equation is solvable by exact, it looks different compared to what we've been seeing so far. So that could give you a crude estimation um, and helping you identify how to solve a first order DE. So now let's convert it into standard form. Okay. Okay. Now let's identify the integrating factor. This is one of the things that I really want to ask, if it's possible to actually do this. Like, I still can't believe that it's actually possible. Verify. This is number 14. Integrating factor is, yup, x e raised to x. Okay, so given x e raised to x, we multiply it by the standard form. Okay, let's now focus here. X e raised to x dy over dx plus cancel. Perfect. Okay. Then we have y here and the integrating factor. Okay. And then just copy whatever is at the right side. You bring the x to the right side, so integrate. u is equal to 2x. du is equal to 2 dx. Okay. Okay. And then simplify. Divide both sides by x e raised to x. Let's see if that's the correct answer. Negative cosine 2x, 2xy raised to... Okay, yeah, this is correct. Nice. So that's basically how you solve linear first order DEs. Let's just continue. I'll just keep answering. I'll stay muted. So yes, this example is linear in x, not in y. So the standard form is expected to be dx over dy plus p of y times x equal to q of y. So let's show that for over y times x. Okay. So move this to the left side. And then for y raised to 5. Okay, so this is linear in x for sure. Because we had trouble solving it a while ago when we thought that it was linear in y. Okay, so let's now identify force of habit. P of y is equal to 4 over y. Q of y is equal to 4y raised to 5. And okay, now let's identify the integrating factor. A raised to integral p of x dx equal to integral for p of y dy. Okay, dy over y, that is ln y raised to 4, cancel y raised to 4. Okay, so that is the integrating factor. Now let's multiply it by the standard form. Y raised to 4. Okay, so y raised to 4 dx over dy minus 4xy raised to 3 equal to 4y raised to 9. Okay, so right now, as I said earlier, since this is linear in y now, we find the x. Multiply it by the integrating factor, which happens to be a y variable. I think that's what's supposed to happen. Okay, so you cannot make a mistake here. It's hard to make a mistake if you think it that way. Okay, then integrate xy raised to 4 equal to 4 y raised to 10 over 10 plus c. Now let's solve for x. Divide both sides by y. 2 over 5 y raised to 6 plus c y raised to negative 4. Let's verify. What number is this again? Number 15. That's interesting. Where did y raised to 9 come from? The integrating factor. Wait a minute. 4 over. What is our p of y? What? Ah, oh no. I keep forgetting the minus sign. My bad. My bad. So that's supposed to be 1 over y raised to 4. Okay. 4x y raised to 5. Ah, okay, so that's gonna be 4y only. So the x is still as is. Just like you wrote it like that. Integrating factor is 1 over y raised to 4. Okay. Okay, so let's rewrite. X over y raised to 4 equal to 2y raised to 2 plus c. Ah, wait. No. X equal to y raised to 4. No. 2 over y raised to 2 plus c y raised to negative 4. No, 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 no. Another mistake. If you want to isolate y raised to 4, you don't divide because it's already in the denominator. You multiply both sides by it. Problem solved. This is the final answer. That's for number 15. Okay. Let's do this. Y dx equal to I have a feeling that this is linear to x. Linear in x. Yes, it is linear in x, I believe. First things first, this is not variable separable. This is also not exact. And yes, linear in x. Okay, just keep practicing. Linear in x, so meaning, okay, let's try to convert what we have right now into standard form. For linear in x, that is dx over dy plus p of y times x equal to q of y. Such that, let's fix the equation first. Then we can identify p of y and q of y. So divide both sides by y. Simplify. Okay. Dx over dy equal to okay. Transpose this to the left side. So plus 2x, no, 2y, 2 over y times x equal to e raised to y. Okay, so P of y is equal to 2 over y. Q of y is equal to e raised to y. Okay. What's next? Okay. Multiply the standard form strictly in the standard form, so it's not that confusing. Because it has to be in standard form for the next step. Um, no. What do we multiply it with? The integrating factor. We haven't even found it yet. That's the next step actually. Integrating factor is equal to e raised to integral p of x. Sorry. Since this is linear in x, we have p of y dy. Okay? So 2 dy over y 2 ln of y ln of y raised to 2 y raised to 2. Cancel. Okay? So that's how we got y raised to 2 as our integrating factor. We multiply it now to the standard form. 2 x y equal to y squared e raised to y. Just keep going. Okay, d over dy times x, no? And the integrating factor, y squared. Then just copy the right side. dy. Okay. Integral xy squared equal to... Okay, definitely we need to do integration by parts. That's not going to be hard though. Okay, u is y squared, v is e raised to y minus integral v du. Okay, next. U v minus integral v du. Okay, correct so far. Y squared e raised to y. Don't forget, we are still... So that's a pretty long process for just one side of the equation. But this is not going to be solved by integration by parts anymore. We can just use u du. And essentially, that's just e raised to y. Don't forget the plus c. Okay? Can we cancel something? No. No. We cannot. Now let's divide both sides by y squared. Okay, this is the general solution. Another way, because the answer key is in a different form, let's just verify it if it's the same. So essentially, it's y squared e raised to y minus 2y raised to y plus 2 raised to y times factor raised to y, sorry. Raised to y squared minus 2y plus 2 plus c. Okay, that's it. Yeah, either way, both are the same. So, okay, that's it for 16. Let's try 17. Okay, 1738. How many questions do we still have? 24. 24. Oh no, not 24. I think this reaches 30. 27. How long has this been going on already? 1 hour. Oh, wow. So just 5 questions for an hour. Wow. Just wow. Should I take a break at this point? Maybe after this question. So yes, it is fun to solve. It really pays off if you practice properly. But the tendency is you still experience burnout in the micro sense. So even I need to take a break. Let's see. What if we isolate cosine? No, we isolate dy. Do you think this would be, what do you call this? Do you think it would be linear to in x or in y? Maybe it's not linear in x because of this. And yes, x is clearly associated with a transcendental function. Y is, well, it is, moreover, we can say that this is linear in y. Is it linear? No. Is it variable? Sorry. Is it variable separable? Let's see if I've had examples of variable separable that has transcendental functions. Maybe that could give us a clue. Yes, actually. But the thing is, let me show you. Ideally, I discuss variable separable in a different video, but just so you know what we're looking at right now. Sorry. So this is what variable separable is supposed to look like. Essentially, for example, here, so there's one thing in the first term and another thing in the second term that we can right here. So we can divide. So what we end up with is essentially here tan x dx and then cotangent y dy. Essentially you have x dx here and y dy. That's when you start integration and then you simplify. And that's how you get the general solution or the final answer. Actually, you can still simplify this further. Y is equal to arc sine of this one, whatever this is. So I didn't continue the solution anymore. But yes, that is for variable separable. Here, so you can divide so that what you have is that you have x and then dx. Here you have y and then dy. Okay? The rest is just what you learned from integral calculus. So this is arc sine. And then unit circle, identify what is, so given that y of 0 is square root of 3 over 2, what is that in the unit circle? So arc sine of 0 is what? But yeah, it's just here. Sorry. Okay. So, okay, back to where we are. Back to where we were. This is linear in y. So let's now convert it into the form dy over dx plus p of x times y equal to q of x. What time is it? 10:46. Time is really fast. Wow. I'm about to reach 4 hours of studying. Wow. Cos 1 over cosine x is also secant x. Okay. Okay. Integrating factor. Oh, wow. Wow. Okay, I need to review on the basic property. So integral tan u du is equal to negative ln. Okay, we're correct so far. Whew. If ever, instead we have this cotangent x dx, that's equal to ln sine x. Okay, so only if. So we can bring the negative sign to the exponential position. Then we can cancel. So we have 1 over cosine x raised to negative 1. I believe we can also rewrite this as this. I'll have to ask this back. Not really sure. I don't think so. That's my hypothesis. Or we can just rewrite it as this. And then this. Comprende? Oh, ouch. 17. What is the integrating factor? Secant x. Precisely. Precisely what we got. Okay. So now, going back to the standard form, dy over dx plus y tangent x equal to secant x times integrating factor secant x. Okay. Okay, so we cannot cancel anything. I thought we would be able to cancel something, but no luck. We cannot. Because later on we need to write this one out. Okay. Nice. These cancel. This is the final answer, the general solution. Let's confirm if it's correct. Sin x plus... Okay, sure. This is already an acceptable answer, I believe. The answer key is... So just the inverse. But essentially it's the same. Okay. I'll take a break. Then hopefully we'll be able to answer a few more. Either that or I move on to homogeneous already. I don't really have much time anymore. But yes, thanks for watching.